Alright, let's look at, hopefully we'll be able to finish this up in this video. So let's take a look at 15 and 16, kind of go together, find x and y. If you look at this, there is a theorem about this being the mid-segment and hitting the midpoint of these opposite sides. It talks about the length of this compared to this. This would be half of this length right here. They'll be parallel to each other. But really on this problem, we don't have to worry about any of that stuff. All we got to do is see that this segment right here and this segment right here are equal to each other. So we just set those equal to each other, set these equal to each other, and we've got x and y. That's all there is to it. So let's do that. Oops, there I go again. Let's try this now. Okay. Got 4x minus 35 equals 1/5 x plus 3. Subtract the 1/5 x from both sides. Okay, that'll cancel out. Add a 35 to both sides. That'll cancel out. So let's see. 4 minus 1/5 would be what? 3 and 4/5, or you could think of it like this. Put this, think of this as a common denominator of 5, so this would be 20/5. So 20 minus 1 is 19/5. That's the way I like to do it, as a fraction. Equals, this is 38. Multiply both sides by 5 over 19. Multiply by the reciprocal. 5 over 19. Alright, look at this. That goes once, that goes twice. X is 10. So that's x. Let's do the same thing for y. It's a little easier, actually. 5y minus 8 equals 2y plus 1. Subtract 2y from both sides. Add 8 to both sides. Divide by 3. Y is 3. That's all you need to do. Solve for x and y. Easy. Alright, let's look at 17 and 18. There's a couple ways you could approach this problem right here. There's a little lesson in this chapter that talks about an angle bisector, and as far as these segments that are broken up right here, see this YW and XW, they're proportional to the sides. You could go through a couple ways to do this. I'm looking at this problem and I'm looking at this. Watch. I've got an isosceles triangle, right? Because I got 12 and 12. And look at this side right here. It's reflexive property. So look what I have. I got side, angle, side, and side, angle, side. These two triangles are congruent to each other. If these two triangles are congruent to each other, that means that this segment and this segment would be equal to each other. If they're the same and they add up to 14, then guess what they both are? I'm sorry, they add up to 28. I was getting ahead of myself. They add up to 28, and they both must equal 14. That's one way of looking at it. Let's do it the way that they probably want you to approach it in the book, because these aren't necessarily always going to be equal to each other right here. So let's work on it kind of pretending that we don't realize that they're really equal to each other. So what I'm going to do is I'm going to call this little side, I guess let's not call it x. Oopsie daisy, what did I just do? Let's get rid of that. There we go. Let's just call it like A and B. Actually, I'm not even going to call it B. If I call this part A, this whole thing is 28. So I'm going to call this part right here 28 minus A. Okay, so now let's do this. What does this theorem say? This theorem says that these two segments are proportional to the sides. So I could write it like this. I could write A to 12 equals 28 minus A to 12. Alright, let's see what happens here. Actually, watch what we can do. We can multiply both sides by 12. If I multiply both sides, I'm not even going to go straight to the cross multiply just because this works out kind of nice. I could multiply both sides by 12. So if I multiply this side by 12, you get rid of that. If I multiply this side by 12, you get rid of that. That's one way to do it. So A equals 28 minus A. Let's do this. Let's add an A to both sides. So that'll give me a 2A equals 28. And guess what? Just like we thought, A is going to be 14. Now what did we say the A was? The A was the YW, which is 14. Now, of course, you take that away from 28 right here. 28 minus 14 is also 14. So both of these are 14. This is probably the reason, or the way that they want you to consider it and think about it in the book, but there's a couple ways you could approach this. Alright, we're getting close to done here. Next to last problem. If the length of a scale model is 9 inches and the actual length of the ship is 150 feet, what's the scale factor of the model? Now notice, the scale model was measured in inches and the actual length of the ship was measured in feet. In order to do a scale factor, we need to have these in the same units. It's probably easier to do this. Let's compare the small one to the large one. The only thing is we don't want to simplify like this, because look, I've got inches on the top and I got feet on the bottom. They're not going to cancel out. A scale factor is just a number. It's not going to have any units to it. For instance, if something is twice as big or 3 times as big, or if something is 1/3 as large or 1/2 as big, you're not going to have any units, so we need to change it. Now you could change this to feet if you wanted to, but I wouldn't, because you're going to get a decimal here. I would change this to feet. So what I'm going to do is keep this 9 inches and then just change 150 feet to inches. Well, if I have 150 feet, here's a unit conversion. This is the way I like to do it. If feet's on the top, if you put feet on the top, feet's going to go on the bottom, so they cancel out, and I'm going to change it to inches. Well, how many inches equals how many feet? 12 inches equals 1 foot. So the feet cancel out, so it's just 150 times 12. Well, 150 times 12 is 1,800. 1,800 what? Inches. Now, look what's going to happen. I don't have 2 different units, top and bottom. I have the same unit. So now look what happens. The inches cancel out, and then I've got 9 over 1,800. Simplify that. That's easy to simplify. That goes once, that goes twice. It's 1 over 200. Now, if you're comparing the scale to the actual, it's 1 over 200. Or, if you wanted to compare it from the real to the scale, you could say 200 to 1. Either way that you want to write that, I would accept. It's no problem. Alright, here we go, the last one on Chapter 7. I drew a couple pictures on here already. When a 15-foot tall wall casts a 20-foot shadow. So let's say this is the 15-foot wall, and this would be the 20-foot shadow going around like this. Then it says a building casts a 32-foot shadow, 32 feet. And the question says find the height of the building. Now, what do we know about these? I guess we're making an assumption that it's the same place and same type of day and that kind of thing. So the sun's angle will be the same. So this angle will be exactly the same on both of these. So these are going to be similar triangles. Again, we're assuming that this is the ground and this is the height, so it's perpendicular. And we're assuming that this angle right here is the same. So we do have similar triangles, so we can say the sides are in proportion. This was supposed to be a right angle. So we could say the sides are in proportion. We could do this all kinds of different ways. Let's just do it like this. Let's compare 15 to 20. We'll compare one side to the other on this triangle, and then do the same 2 corresponding sides on the other triangle. Let's go x to 32. And then you can simplify this. You can multiply these out, but watch. 5 goes into both of these 3 times and 4 times. Alright? Let's get rid of the 32, so we multiply both sides by 32. So that'll go. So watch. Multiply that by 32. There's all kinds of ways you could do this. This is just how I chose to do it. Let's see. 4 goes into 32 8 times. 8 times 3 is 24. So x is 24. So that means the height of the building is 24 feet. Alright, that's it for Chapter 7. Make sure you go over these. It's been a while since we've done this stuff, so good luck on this part of the test.